Okay, hi everyone, and welcome back. Real quick before we get to problem C, I just want to reiterate one thing. I remember spending a ton of time reminding us in the part 4 section, right, with these angles that we talked about right here, that the relationship is the angle equals the arc divided by 2 if our angle happens on the edge of the circle, right? On the edge of the circle. Then it's angle equals arc divided by 2. What I wanted to be a little bit more clear about in this section was where our angles are formed for the arc plus arc divided by 2 relationship to occur. And remember, in our learning target, it's all about forming angles on the inside, or outside. So on is like our old stuff, simply arc divided by 2. But as you can see, right, these intersect on the inside. And so what we've been working with over the last video with the arc plus arc divided by 2, that only occurs when our angles are created inside the circle. And so looking at example A, right, intersection inside the circle, inside the circle, inside the circle. Now be careful. Notice none of those intersection points are actually the center of the circle. These are not centers. If they were centers, those would be central angles, and that has a different relationship. We talked about that, I believe, in the part 2 video. These just intersect somewhere inside, but again, not the center. So inside, 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 and then on these three as well. Inside, inside, and then this last one, inside. Anytime it's inside the circle, we get that our angle equals the two arcs added together, so arc plus arc, and then divided by 2. And so let's apply that right here. Remember, find your angle. So here's our angle. Across from it is one of the arcs we want to add together. Find its vertical angle, so that's the opposite side of the intersection. Across from that one is the other arc. And so we'll just do our angle, which is 115, equals arc plus arc divided by 2. So 105 plus x divided by 2. And as always in this section, we'll clear that bottom of the fraction by timesing both sides by 2. And the 2's cancel. So on the right, we just get 105 plus x. And then 115 times 2 is 230. And then we will just subtract 105 from both sides, and that will leave us with x. And in this example, x is going to equal 125. 125. All right, so all of those problems deal with angles on the inside, and then that angle is arc plus arc divided by 2. Now, there's a second part to part 21, right? Because if you look at that learning target, it's angles on, which we covered, inside, which we just covered, and now we got to talk about what happens if we draw these lines and we create angles outside of the circle. So there's one more property for that. So let's go through the theorem. Theorem, if two tangents, two secants, or one of each intersect in the exterior, and remember exterior means outside, so outside of the circle, of a circle, then the measure of the angle formed is half the difference. And remember what difference means. That means like minus. So we are going to subtract here. So the angle is half the difference of the measures of the intersected arcs. And so we're going to draw three pictures because it can be two tangents, two secants, or one of each. Now, don't concern yourself too much with all these vocabs. As you'll see, we'll see 1,000 different examples in this note packet, plus a whole bunch on the worksheet, and they all operate the same way. And so again, don't concern yourself too much with the vocabulary here, but I just want to show you kind of the different setups that we can have here. And so here's one of the situations. Let's say here's where our angle is coming through, and then here's a secant, goes through the circle. And then this other one is a tangent line. So we're just going to hit the circle one time. Now that's not a perfect line, but let's just say we hit it one time. And so we need to look at arcs in between these two lines. So this is the angle we're talking about. And remember up top, we said the angle equals half the difference of the two arcs. Now here's our two arcs. The farthest arc away is this. This is in between, right, our two sides of our angle. And so that's one of our arcs. This is an arc. The other one is closer to our angle, but still in between our two sides, right? So that's our other arc. And so out of all three of these diagrams, the equation is angle equals, and this time it's arc minus arc divided by 2. And so here's another picture. Let's say we have angle on the outside, and this time we have two tangents. So right there and right there. We still have the same situation. Farthest arc away is between those 2 points of tangency. So that's the blue one, that's one arc. Closer piece right here, that's still another arc. And as always, that's our angle on the outside, right? Angle on the outside. And again, angle equals, and this time arc minus arc divided by 2, right? And I'm going to draw one more picture, but same property. One more picture, same property. This time we're going to do two secants. And so straight through the circle there, maybe straight through the circle there. So here's the angle we're talking about. Farthest arc away, remember always in between the two sides of our angle. So it's that one, that's an arc. Here's another one, that's the other arc we're going to work with. And just like it's been, our angle equals arc minus arc divided by 2. So with all that in mind, let's apply it with some numbers, right? So here's our angle. We're looking for measure of angle 1. So the measure of angle 1 is going to equal the far arc in between the two lines, so that's 170, minus the close arc still in between the two lines, so minus 30, and then divide by 2. 170 minus 30 is 140, and then 140 divided by 2 is 70 degrees. So that angle had to be 70 degrees. Perfect. Now let's do B. Here's angle 1, right? And so we're still looking for this angle right here. So measure of angle 1. Now, there's a couple issues that we got to think through on this problem. First of all, these are tangent lines, so they do hit the circle in one spot. And so one of the arcs we're talking about, our biggest arc, goes on the outside from dot to dot, right? And so angle 1 will be 270 minus this other arc. And I'll do it in red, and that's the other way from dot to dot. But we don't have a number for that. But notice none of these lines go through our circle. So our circle's not getting cut at all. Remember, a full circle is 360 degrees. Well, if from dot to dot along the outside is 270, and we still have our full circle here, then the red arc is 360 minus 270, right? It's whatever else is left of the circle. And 360 minus 270 is 90. And so that red arc has to be 90. So again, our angle, which is measure of angle 1, like we're talking about, arc minus arc divided by 2. 270 is the big arc. We just found that the little one is 90, and then we'll divide by 2. And so 270 minus 90 is 180, and then 180 divided by 2 is 90. So angle 1, 90-degree angle. All right, now let's do C. So here we go. We want angle 1, right? And so we need a big arc, a far away arc in between our two sides. So that would be this blue arc, which we don't know. And then we need our close arc, which is the 134-degree arc. Now, we don't know the blue arc. We do know the green arc. And then we have this random one on the outside that we, isn't applying in this situation. However, it's the reason why we can figure the blue out, right? A whole circle equals 360. We don't want to count the green arc for part of the blue arc, so let's subtract the green arc away. And also, we don't want to count the 12. But the blue is the whole rest of the circle, not including 134 and 12. So if we minus the 134 and we minus the 12, we are going to get what the blue equals. And so 360 minus 134 minus 12 is 214. So the blue is 214. And so now our angle, which is measure of angle 1, it always equals big arc, so 214, minus little arc, 134. And remember, we're always talking about the arcs that are in between the sides of our angle. So big arc minus little arc divided by 2. 214 minus 134 is 80. So we have 80 divided by 2, and 80 divided by 2 is 40 degrees. Perfect. And I just want to make one thing clear. Notice all of these are outside, right? Outside the circle. This angle, outside. This angle, outside. And so arc minus arc divided by 2 always deals with angles on the outside. Well, let's keep going. All right. So we want to find angle 1, this angle, right, on the outside. And so it's going to be arc minus arc divided by 2. We got to figure out our arcs. So our big arc all the way across in between our two lines is 85. The arc that's real close to our angle in between the two lines is this really small one. And we don't know a number for that. But we know all these other numbers. And we know that our circle has to add up to 360, right? And so this little small arc will be 360 minus all the other parts of our circle. So minus 175, minus 85, minus 95. And when we do all of that, we get that this little arc literally only equals 5 degrees. But that's okay. And then remember, our angle is going to equal arc minus arc divided by 2. But the two arcs that we're talking about are the ones that are inside our two angles, or the sides of our angle, right? And so the measure of angle 1 is going to equal 85 minus 5 divided by 2. And that equals 80 divided by 2, which once again equals 40 degrees. 40 degrees. All right, let's keep cruising. Here's our angle right here, right? Angle 1. And so that arcs that are in between the two sides of our angle, the big one on the outside is 170. We do not know the little one right here, right? But for the third time in a row, right, we have this other thing on the outside. So if we just do 360 minus the other two parts, 135 minus 170, it'll tell us what that close little arc should be. And when we do this, we should get 55. So then the measure of angle 1, angle equals arc minus arc divided by 2. We're talking about the arcs in between the angles, right? And so 170 minus 55 divided by 2. When you do that, you should get 115 divided by 2. And 115 divided by 2 is 57.5. All right, now the last one, and that'll take up the rest of the time for this video, and we'll quickly finish after that. This one involves multiple things. So first of all, this 66-degree angle, that's an angle on the edge of the circle. And so the arc it opens up to is this arc. And remember, angles on the edge are half of what the arcs are. And so the red arc that I've highlighted here is going to be 66 times 2, which equals 132, right? So this brings back, going back to the part 4 video. This starts with an angle on the edge of the circle. And we got to remember what to do with that. And so we times it by 2 to get what the arc is, and that is 132. Now, we need to ultimately, to figure out angle 1, this is an outside angle, we need to do arc minus arc divided by 2. But for us to get the other arc, we need to know this whole green piece, right? And all we know is the red piece. The red piece is 132. But those angle, right? Angle 1 doesn't cut this circle at all. And so if 132 is the red part, the rest of the circle is the green part. And we get the rest of the circle just by doing 360 minus 132. So the rest of the circle has to be a 228-degree arc. And now we've got the outside green arc, and we've got the inside red arc. And so our angle 1 is just going to be 228 minus 132 divided by 2. And when we do that calculation, we should get 96 divided by 2, which tells us this is a 48-degree angle.